Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Mr. Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Right, today we are looking at trigonometry, but we will be focusing on the introduction to compound and double angles. Hopefully you guys are going to follow, and please make sure that if you have questions, please send them through. Questions about this lesson, send them through to our WhatsApp line. It's open, 064-748-8913, 064-748-8913. That's where you can interact with us if you have questions about the lesson that we're just going to start now. Right. Let us look at the lesson objectives. We checking what you should know at the end of this particular lesson. You should be able to apply, to derive and apply the formula for compound angles, and that formula that we're talking about here is not examinable. And then you should but then use that particular formula to prove the rest of the compound angles. To prove the formula for cos A minus B, cos A plus B, sin A minus B, and sin A plus B. And then you should be able to solve simple problems using compound angle formula. You should be able to use compound angle to derive formula for double angles. You should be able to solve problems using double angles. And you should be able to solve problems requiring the use of Pythagoras theorem and without the use of a calculator. You should be able to solve problems where trigonometric ratios are represented as letters. So today's lesson, you observe that it is less focused on the use of a calculator. Most of the things here would be doing them manually. Right, obviously this you can check on your exam guideline on page 8 to see the scope within which you should prepare your trigonometry work. Right, the knowledge that you should be bringing to the lesson, you should know how to define trig ratios using the sides of a right angle triangle. You should know how to define trig ratios in a Cartesian plane. You should know how to use and apply the reduction formula, the cofunctions, negative angles, multiple rotations, special angles, and you should also know your basic trigonometric identities. I think all this pre-knowledge that was listed here was covered in our lesson that we had last week. Right, moving right along. Now we are going to look at the proof of cos A minus B. Cos A minus B. This one we are going to look at the numerical proof of how to do it, but remember the proof is not examinable. So you are not required to know this proof for exam purposes. However, this formula here that you conclude right at the end, you should be able to use it to derive the other compound angle formulae. Right, now how do we go about it? We are going to put two terminal rays. The first terminal ray would be in the first quadrant. This would be that terminal ray. And then from there, we're going to have that the angle of inclination for that terminal ray is alpha. And then we call that terminal ray, ray R. Now we are going to have a ray of the same length as R, but in the second quadrant. So this is also called ray R, and then we let the angle of inclination of that particular ray be alpha. And then you can see now that we've developed a triangle. If we are to join the two terminal rays, we've developed a triangle, and in this triangle, there is an angle here which we can calculate. Remember, the total or the big angle, the obtuse angle there is beta. and the acute angle there is alpha. So the difference between the two, beta minus alpha, would give us that interior angle in the triangle. And we also know that we have this as at the terminal raised r, and then we can use our trigonometric ratios to can write down the coordinates of point B and the coordinates of point A using those terminal rays. Remember the cosine of alpha would be given by, let me write it somewhere here. The cosine of alpha would be given by the adjacent over hypotenuse, which is x over r, which means that x would be r, the cosine of alpha. That is where this comes from. Similarly, sine alpha would be y over r, which means that the y value would be r sine of alpha. We do the same with this one. Now that you've completed the set of ordered pairs for point A and point B, we are going to use our cosine rule in this triangle. So if we use our cosine rule to work out the length of AB, we can see that it should be r squared, or AB squared is OA squared plus OB squared minus the product of OA and OB times the cosine of the angle AOB. Now, if we substitute, we can get that this is r times plus r squared plus r squared minus 2r times r, the cosine of beta minus alpha, and this lends us here, where we have AB squared is 2r squared minus 2r squared, the cosine of beta minus alpha. Now, similarly, remember you can determine this length of AB using the cosine rule. However, one can also use the distance formula to determine the same length. Now, what are we going to use here when we use the distance formula? We're going to be using these set of ordered pairs. We're going to be using those coordinates there. Now, when we use the coordinates to determine the length of AB, we're going to say that's AB squared, which is x2 minus x1 all squared, plus y2 minus y1 all squared. Substituting the x and the y values in the formula, we get that this is r cos alpha minus r cos beta all squared plus r sin alpha minus r sin beta all squared. Now, after that, when we square everything, you square the first term, you get r squared cos squared alpha. You twice the product would be r squared cos alpha cos beta. If you multiply that by 2, you get 2r squared cos alpha cos beta. You square the last term, you get r squared cos squared beta. Similarly, here on the next bracket, you square the first term, you get r squared sin squared alpha. You multiply the product by 2, which is 2r squared sin alpha cos beta, and then you square the last term, you get those results. Now you can simplify, can check that on the first one we took out r squared as a common factor. Also, we took out r squared as a common factor. For those that have angle alpha, we took r squared as a common factor. We are left with cos squared alpha plus sin squared alpha. For those that contain cos beta, we take r squared as a common factor as well. We get cos squared beta plus sin squared beta, and then we get that this is the remaining part here, which was this one, as well as that. We've written them here. And then from there, obviously, cos squared alpha plus sin squared alpha is 1. So we're going to get that this is 2r squared. Similarly, cos squared beta plus sin squared beta is also 1. So this would be r squared, and this would be r squared. When you add the 2, you get 2r squared. And then from there, we can factor out r squared here in the last two terms. If we factor out negative 2r squared, we get cos squared of cos beta cos alpha plus sin beta sin alpha. And then from there, we are going to then equate. Remember, we have the length of AB squared from the cosine rule. We have the length AB squared from the distance formula. If we equate the two, we equate these results together with the results that we got here, and then when we simplify, we get that this is 2r squared minus 2r squared cos beta minus alpha. Similarly here, we get the same. If we divide both sides by 2r squared minus 2r squared, we are going to get that this would be the cosine of beta minus alpha, which is cos beta cos alpha plus sine beta sine alpha. So this would be the proof. We were then successful in proving the compound angle expansion for the cosine. Remember, the proof is not for exam purposes. However, what is coming now is required for exam purposes. This you need to know for exam purposes. It was examined in the 2024 November paper, so it's something that you should know. So we are trying to take you through how to actually do that. Now, let's look at the first part here. We use, remember this one, the one that they say we must use. This one is from what? From the proof. It's from the proof. Which proof? This proof. It's from this proof. We've done it. There it is. So we want to use it to prove the rest. Now, let's look at the first one. Cos A plus B. We check what we are given. The goal is to write down what we have, what we are given, or what we are required to prove. We want to write it down in a form that looks like what we are given. So we have the first angle, subtract the second angle. So we want to write this one, cos A plus B, as what? The first angle minus the second angle, so that we can be able to use this expansion. So the first thing that we are to do here is we are going to say, but we can let this be cos A minus what? Negative B. Because we know that negative B is a negative angle. So if you check now, we've written this as a difference of two angles. First angle is A, second angle is B here. Difference of two angles. We did the same here. First angle is A, subtract, the second angle is negative B. So we've written it as what? A difference of two angles. Now, let's check here. That is the first step. Writing A plus B as what? As a difference of two angles. Then from here, we can then use the given expansion. Which means if we have the first angle, subtract the second angle, in order to write it as an expansion, it's the cosine of the first angle, the cosine of the second angle, plus the sine of the first angle, the sine multiplied by the sine of the second angle. So we need to do the same here as well. So we have that this is the cosine of the first angle, A, times the cosine of the second angle, negative B, plus from the formula there, the sine of the first angle, A, times the sine of the second angle, negative B. Now, simplifying that using our knowledge of negative angles, we get that obviously the cosine of negative B is equal to what? Cos B. But the sine of negative B would be negative sine B, because negative angles are on the fourth quadrant and cos is positive on the fourth quadrant, sine is negative on the fourth quadrant. So that is why this one is written as what? Negative sine B, but this one is written as just the cosine of B. Right, moving right along. Can see now we multiplied here so that we have plus multiplied by a negative, we get a negative. So the formula there would be cos A cos B minus sine A sine B. And this formula is representative of what? The cosine of A plus B. Good people, remember this is very, very important. It's very, very important for exam purposes. Very, very important. You should know how to do it. Right, I'll explain it again. The aim is to write down what you are supposed to prove. You write it down in the form of what was given. So we were given A plus B, or rather, we supposed to prove the cosine of A plus B, but we are given the cosine of A minus B. So we want to write A plus B as a difference of two angles. So we said it's A minus negative B, which algebraically is still A plus B. Right, we move on to the second one. The second one, if you check now, it's written in the form of sine of A plus B. The sine of A plus B, what is the aim? The aim is to write it as the cosine first. And then after writing the sine as a cosine, you should be able to express it as what? As difference of two angles, because that is what we are given there. We are given the cosine of the difference of two angles. Now, remember, I am now taking you back to cofunctions. We need to know how to reverse our cofunctions. So I am taking you back to cofunctions. With our cofunctions, you know, if you have the cosine of 90 minus theta, that is the same as what? Sine theta. So in order for us to write down the sine as a cosine, it should be the cosine of what? Of the complement of that particular angle, because the sine and the cosine are cofunctions. They are complementary functions. So we will write it as what? As 90 minus theta. So the cosine of 90 minus theta becomes the sine of theta. So I have the sine of A plus B. I want to write it as a cosine. So it should be the cosine of what? 90 minus what? Minus A plus B. So that should be the first step. Now we have written it down in terms of what? In terms of cos, because we were given the cos in the original one. Now we need to make sure that also the issue of the difference of two angles there is taken care of. Remember, here you can see it's a difference of two angles, it's okay. However, this one here does not contain a variable angle, it just contains the 90. So we need it to contain that variable angle. Right, let's check here. First step, obviously, I have already taken you through that. We are writing the sine as the cosine of 90 minus A plus B. Now we are going to distribute the negative there. We were going to get negative minus A minus B. Then we group 90 minus A so that it becomes the first angle, because you can see here the first angle must contain A and the second angle must contain B. So this first angle contains A, it is written as 90 minus A. And the second angle now is what? Minus B. So you can see that now this is written as the cosine of the first angle minus the second angle. Now we can go to the expansion. Now, if you look at the expansion here, it says if you have the cosine of the first angle minus the second angle, you should write it as the cosine of the first angle times the cosine of the second angle plus the sine of the first angle, the sine of the second, multiplied by the sine of the second angle. We are going to do the same here. Look at what I have there. The cosine of the first angle, which is 90 minus A, times the cosine of the second angle, which is B, then plus the sine of the first angle, which is 90 minus A, times the sine of the second angle, which is B. Now we simplify. The cosine of 90 minus A, this one becomes the sine of A. Then we leave this one as is. The sine of 90 minus a becomes the cosine of a. We leave that as is. So we have now successfully also derived the formula for sine a plus b. So we've derived one for cos a plus b, we've derived another one for sine a plus b. Now, there's an activity for you here. I want you to now do the last one, the sine of a minus b. Using the skills that I've just given you, you should be able to prove that one as well. Should be able to prove that one as well. I am going to give you 5 minutes to do that. Please make sure that you write it as quickly and to the best of your ability as you can. Right, your 5 minutes time starts now. Right, hello and welcome back. Hopefully you were able to work it out. This one is a bit nice, it's a bit tricky, but I am confident that you guys got it correct because it uses the same mathematical skills that we were using for the others. Now let's go through it together and see what you guys were supposed to do. Now, look at this. It's sine A minus B. The first thing that we need to do is we need to change the sign and write it as a cosine. So that is the first step. So we need this as a cosine of now 90 minus A minus B. So that's where we start. And then from there, obviously, when we distribute the negative, just like we did with the one before, this would be 90 minus A plus B. 90 minus A plus B, like that. Now, if we are to group these two, like we did with the previous one, we are seeing here that we are having a plus as opposed to having what? A minus. So we are having a situation where we have a sum of the two angles as opposed to having the difference between the two angles. Now, what is it that we need to do in that case? We need to go back to the first one. Remember the skill set. Let me just go one slide back. The skill set for the first one here, for the cosine of A plus B, was to change this plus to what? To a minus by introducing what we call now the negative angle. That was the skill set that was tested on the first one, this one. Now, on the second one, the skill set that was tested was for you to be able to write down the sign as a cosine. That was the first skill set that was tested. Now, if you are to combine the two skill sets, writing a plus as what? A negative multiplied by a negative angle, and also being able to write down the cosine in terms of the sine. Those were the two skill sets that A and B in the examples were testing. Now we do both of them combined here. So we are testing the two skill sets now combined. So when you combine that, you can see that now this becomes the cosine of what now? 90 minus A plus what? Minus what? Negative B. So that is the first skill set. The first skill set here was to change the sign and write it as a cosine. The second skill set was to write down a positive angle as a product of what? A negative sign and a negative angle. So those two skill sets were tested in one particular problem here. Let's see. Obviously, the first one was to write down the sign as the cosine. That was the first skill set. And then from there, we look at the distributive law. We distribute the negative, and then we see that there's a plus. So the next skill set now will then be to writing down a plus B into what? A product of the negative sign and the negative angle. And then from there, we can expand. We expand using the given formula, this one. The cosine of the first angle, which is 90 minus A, the cosine of the second angle, which is negative B, plus the sine of the first angle, which is 90 minus A, the sine of the second angle, which is negative B. Now we can simplify. Obviously, the cosine of 90 minus A becomes what? The sine of A. And then this one, the cosine of a negative angle is always positive. So it becomes the cosine of B because it's located in the fourth quadrant and cos is positive in the fourth quadrant. And then from there, the sine of 90 minus A changes to a cosine of A, and the sine of negative B changes to negative sine B because negative angle is in the fourth quadrant and only cosine is positive in the fourth quadrant. So we can have a step further here. We get that this is cosine A cos B minus cos A sine B. And that would then mean that we were successful in terms of what? Deriving the other three. Remember, those three derivations are examinable. Right. I hope you all understand. I hope you all understand. Remember, if you have questions or there was somewhere where you did not understand, please do ask us on our interactive WhatsApp number there. I think it's at the bottom of your screen there, 06474888913. Do ask those questions. You are going to get responses there. Right. We are moving on now. Now we are going to look at the summary of the compound angle formulae as they appear in the formula sheet. These are the four formulas that we proved. These are the four formulas that we proved, and these are the four. Remember this one came from what? From the derivation. And we said it's not examinable. And then these three were derived from that one. And the work thereof is examinable. So that is the first thing you should know how to do in grade 12 trigonometry. That's the first and foremost thing. Right, let's move and see what next you need to know. Now we are applying the formulas that we proved. We are applying them in order for us to solve problems. Now, expand and simplify, we have the cosine of x minus 60. Now, I'm flagging here the four formulas that appear in the formula sheet. I want to, as I expand, I make reference to the formulas that are in the formula sheet to say we will be using this one. Then we use it together. Right. Now, if you check here, we have the cosine, which means we are either using this formula or that formula. Now we check, it's x minus 60. So we are using the one with a negative. So this is the formula that we are going to use. Cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second angle. That's what it says. Now let's use it. You see, cosine of the first angle, that is x, times the cosine of the second angle, that is 60 degrees, plus the sine of the first angle, that is x, times the sine of the second angle, that is 60 degrees. Now, because we have 60 degrees, and in our prior knowledge, we did say you come into this lesson knowing special angles. So 60 degrees is a special angle. So the cosine of 60 must yield what we call a special ratio. Such ratios can be determined without the use of a calculator. Although now the calculators that you have are more advanced in that they can actually give you the special ratios. Right. Now, let us further simplify that one. You see now the cosine of 60 is half, and half is referred to what as a special ratio. And then the sine of 60 is root 3 over 2, which is also a special ratio because it's a sine of what? A special angle. Now, it means that we can further simplify this, making the half and the root 3 over 2 the coefficients of the trig ratios. And then after that, we can factor out, we can take out a common factor of half here. We get that this is the cosine of x plus square root 3 the sine of x. So that is how we have simplified that one. We've used the expansion, but we also integrated it just a bit with our special angles, which then, when combined with trig ratios, the special angles yield to what? To special ratios when they are combined with those trig ratios there. Right. Now, express the following as a single trigonometric ratio and simplify where possible. Good people, it is of paramount importance for you to know how to expand, just like we've been doing. We are taking cos A minus B, we are writing it in expanded form. Similarly, you should be able to take something that is written in expanded form and be able to also reduce it, or rather I should say be able to also congest it. At times you are given it an expression in expanded form, you should be able to do what? To congest it. So these formulas work from left to right, they should also work from right to left. Very, very important. Now, let's look at how we can go about this one. You can see that we have cosine, cosine. So we are going to check from our formula sheet. You see on the left hand side, I've actually flagged the formulas in the formula sheet. Right, I have a small technical glitch. Let's just take a 1 minute break. Let's just take a 1 minute break to sort that out. Just 1 minute.
1 minute, sir.
Thank you. Right, hello and welcome back. The problem has been sorted. Thank you so much. Right, we are looking at this. I was saying you should be able to use compound angles to expand and also use compound angles to congest. What do I mean? I mean, if you are given this product, you should be able to take it back. Rather than expanding, the congestion is also true. You should be able to move from the right-hand side to the left-hand side, just like you did moving from the left-hand side to the right-hand side. So now let's look at this one. We want to express it as a single trigonometric ratio. Now, what we want to do here is to check which formula will be applicable first. Right, guys, you can see how important your formula sheet is for trigonometry. Very, very important. So you should always have it next to you when you work with trigonometry. Right, now let's check. We have the cos, the sine. Check. We want them to alternate, the cos and the sine. Sine, cos, cos, sine. Sine, cos, cos, sine. So you can see that they are alternating in these two formulas, 1 and 2. So we have to choose which one we should use. Look at this sign here, minus. We're going to check the one here with minus, this one. So it means that we are going to be using formula number 2 there. That is the formula that we have to use. So let's check how we should use it. First things first, I will rearrange and write down the sign, because it's written as cos, sine, cos, sine. So I'll start with sine and then cos. Remember, multiplication is commutative. What do I mean by that? I mean 2 times 3 gives me 6, and also 3 times 2 also gives me 6. So it does not matter which one I start with, as long as I'm multiplying, the results will always be the same. So here I can start by writing this as what? As the cosine, or rather the sine, and then the cosine. Check what I did there. You see, I changed these positions here because that's how they appear in the formula sheet. The formula sheet starts with sine. So I am changing that to sine x sine 3x cosine x plus sine 3x cosine cos 3x sine x. Sorry about that. Made a mistake here. The sign should be negative, not positive. The sign should be negative. That is the error there. Because remember, from the original problem, it was negative. So after I've done that, I've changed them positions. Sine 3x cos x cos 3x sine x. So you can see that your angle alpha is what? Is 3x. And your angle beta is what? Is x. So we can do what this formula here did to alpha and beta. So we took the first angle minus the second angle. So it should be sine of 3x minus x. In simplifying that, we get that this is the sine of 2x. This should be our answer because we've expressed it as a single trig ratio. That is what we were expected to do. Remember, we need to identify the formula to use, and then you should be able to use it from left to right and also from right to left. Right, now we have another activity. I am going to give you again 5 minutes for this activity. It's a very interesting one, just 5 minutes. Please do it to the best of your ability, and your 5 minutes time starts now. Right, hello and welcome back. Hopefully you were able to determine the single trig ratio for this one, and if possible, maybe simplify. If you check here, we have what we call now the numerical reductions. You did this in grade 11. Uh, these are numerical reductions. Now, how do you work around numerical reductions? You are saying any angle that is greater than 90, any angle that is not in the first quadrant, has to be reduced. Any angle that is not acute has to be reduced to an acute angle. Now, if you check here, 320, that is a reflex. 140, that is obtuse. Also, this one is reflex. So we need to be able to reduce our obtuse angles and our reflex angles using the reduction formula that you've learned in grade 11. So we've integrated this particular problem on compound angles together with the numerical reductions that you learned in grade 11. Now, let's go through it. Obviously, the frame of reference are those four formulas there. Number 1, number 2, number 3, number 4. So those are the frame of reference. Now, let's check. First things first, we are going to reduce 320. In order to do that, we locate the quadrant where 320 is. It is in the fourth quadrant. If you are going to just look at the quadrants here, the reduction instructions here, obviously here would be 180 minus theta, 180 degrees plus theta, and 360 degrees minus theta. I'm not writing anything here. This is sine theta, tan theta, cos theta. I'm not writing anything here in terms of the reduction because all the angles in the first quadrant are acute. So I'm writing down the reduction instructions for those that are not acute. So I'm starting with 320. It is in the fourth quadrant. The instruction is 360 minus. So this should be 360 minus what? Minus 40 degrees. 360 minus 40 degrees will give you 320. So you've written it as a reduction instruction. Let's look at 140. 140 is in the second quadrant. It is obtuse. So in the second quadrant, we say 180 minus. So what are we subtracting from 180 to get 140? We should be subtracting 40 degrees. So we'll write 140 as 180 minus 40 degrees. We have another one here. That is 200 degrees. 200 degrees is in the third quadrant. And in the third quadrant, the instruction is 180 plus. What should we add to 180 to get 200? That should be 20 degrees. So that is the first thing that we need to do. We need to then reduce these values by making use of the reduction formula. Right. Let's check the first one now. Let's check here again. The first one, can see these are the reduction instructions that I was telling you about. Now from there, we can be able to apply the reduction formula to reduce this to a smaller angle. So cos in the fourth quadrant is positive. So this yields cos 40. Can see this becomes cos 40. So we managed to reduce 320 to what? To 40 degrees by using what? The reduction formula. So that is why we are saying we are working with numerical reductions. Now, cos 20 came back as it is. Sine of 180 minus 40. It's 180 minus, it's in the second quadrant. Sine is positive there. We've reduced that to sine 40. So we've managed to reduce 140 degrees to 40 degrees, making use of the reduction formula. Now, moving up to the next one, we have the sine of 200. This becomes minus sine 20 because 180 plus is in the third quadrant, and sine is negative in the third quadrant. Now simplifying this further by multiplying this positive and the negative there, so we get that this is negative. So if you check, we have cos, sine, and a negative in between. Cos, sine, and a negative in between, which means we are going to reduce or to congest this using the cos expansion. So from equation 3, we are going back. So this would be the cosine of 40 degrees plus 20 degrees. Cos of 40 plus 20, that is the cosine of 60 degrees, which is equals to a half. So that's how you were supposed to work this one out. Cosine of 60 degrees, which is a half, you reduce to a single trig ratio, and then from there you found that it is the cosine of a special angle, so it gives us a special ratio, which is half. Right, the next one, without using a calculator, determine the cos of 15. So if you check 15 degrees, we need to be able to first write it as compound angles. And in order to do that, in order to write it as compound angles, what we are going to check first is which two special angles can give us 15 when we add them or when we subtract them. So one can go for 60 degrees minus 45 degrees. That gives you 15. One can also go for 45 degrees minus 30 degrees. That would also give you 15. So let's look at that. There are the frames of reference first, and then let's check. The cosine of 15 degrees can be written as 45 minus 60, can also be written as 60 minus 45. This is also okay. Right. So when we are to expand this, it would we are looking at a cos of 45 minus 30. So we are here. That is 45 degrees. That is 30 degrees. So we will expand. That way, cos 45, cos 30, plus sine 45, sine 30 degrees. Then from there, these are special angles, so they yield to special ratios. So we've determined those ratios there. So you are going to get a mark for this expansion. You get a mark for each special ratio there. And then from there, you simplify that further. You are going to get that the cosine of 15 is square root 6 plus square root 2 divided by 4. Because when you multiply the square root of 2 times the square root of 2 times the square root of 3, this becomes the square root of 2 times 3, and this becomes the square root of 6. So this would be the square root of 6 divided by 4 plus square root 2 times 1, the square root of 2 divided by 4. So if you add the two, they have the same LCD, so you're going to just add the numerators, square root 6 plus square root 2 divided by 4. Right, we move on. Now, I have an activity for you here, also for 5 minutes. We are using compound angles to solve problems. We are using compound angles to solve problems. I am giving you 5 minutes to work through that. It's a very nice problem. I hope you will be able to get it correct. Your 5 minutes time starts now. Right, hello and welcome back. Now this one is a very nice one because it is demanding of us to write down special ratios as their corresponding trig ratios of what? Special angles. So we are given those special ratios now as opposed to being given special angles. Like for an example, I'll just take you through one example. If you have the sine of say the sine of 45 degrees, that is root 2 over 2. This side is a special ratio. So one needs to be able to write down root 2 over 2 as what? As the sine of 45. Sometimes you should be required, or you should be having that skill because it is useful to other problems. Like for an example, this particular problem. So it is useful for you to be able to take a special ratio and write it as a corresponding trig function of a special angle. Now, let's look at the formulas here. 1, 2, 3, 4. I am taking you through now. If you check, we have cos, we have sine, and we have a plus. So we have cos, we have sine, and we have a plus. We have cos, we have sine, and we have a plus. So it's either equation 1 or equation 3 or 4, equation 1 or equation 4. You are going to make a choice which one you choose. Let's see which one I chose here. Here I chose equation 1. If it's equation 1, what is the aim? The aim is, because I know I have a cos already, it means I will express this half as what? As the sine. I have a root 3. I have a sine already. If I have a sine already, it means that I will express this one, the root 3 over 2, as what? As a cos. Now, how do you know it should be the cosine of which angle? It should be the sine of, you will now take the inverse, because you know it should be the sine. So you will take the sine, the inverse of the sine of what? Of that special ratio. It should yield to the special angle. The arc sine of half leads to what? 30 degrees. So you will know it was the sine of 30 that gave us what? That gave us a half. Similarly, here you have root 3 over 2. We are saying we want to write it as a cos because we are interested in writing this as equation 1. So this would be the arc cosine of root 3 over 2, or the inverse of cos of root 3 over 2. This gives us also 30 degrees. So you know that if you have the inverse of cos of root 3 over 2, this gives you 30 degrees, which means that we can write down half as sine 30, we can write down root 3 over 2 as cos 30. Since we are using equation 1, what we are going to do now is we're going to write this as a single trig ratio, sine cos, cos sine. So this simplifies to the sine of what? 30 degrees plus x. So we've expressed it as a single trig ratio. Making use of the special ratios being taken back to the trig functions of their corresponding special angles, and then we were simplifying using compound angles. Right, we move on. Now we are going to use compound angles to derive formula for double angles. Let's first derive the formula for the sine of 2 alpha. So this as a compound angle is alpha plus alpha. That is sine 2 alpha. Is written as what? Or let me do this. sine 2 alpha is written as what? Sine alpha plus alpha. So we can actually here use our glossary here in terms of sine alpha plus alpha. This would be the formula that we're going to use. Sine alpha plus beta, sine of the first angle plus the second angle. This becomes sine alpha cos alpha plus cos alpha sine alpha using equation 1. And then from there, this becomes 2 sine alpha cos alpha. So this is the double angle expansion for the sine of 2 alpha. So that's what we get there. Right, I am moving on. Next one, we want to write down the compound angle formulae for cosine 2 alpha. So cosine 2 alpha would be the cosine of alpha plus alpha. So we've expressed 2 alpha as the sum of two as the sum of two angles to form what we call a compound angle. So now this can be written as, let's check in our glossary there, the formula sheet. It's this formula here that has to be used there. So we're going to have cos alpha minus sine alpha sine alpha. So this becomes the cos squared alpha minus the sine squared alpha. This is equation 1. It's equation 1. This is written in terms of cos and sine, in terms of cos alpha and sine alpha. However, we also know, that sine squared alpha plus cos squared alpha is equal to 1. That we know from grade 11. Sine squared alpha plus cos squared alpha is equal to 1. That we know from grade 11. So what are we going to do here now? We are going to then write this one in terms of cosine only, which means that we can then change, if we want to write it in terms of sine only, we can have that the cosine squared of alpha is 1 minus sine squared alpha. We can come and substitute it in the original one. Where we see cosine, we put, remember we have cos squared alpha minus sine squared alpha. So where we see cos squared alpha, we put 1 minus sine squared alpha and then minus sine squared alpha. So this becomes 1 minus 2 sine squared alpha. This is equation 2. This one is expressed in terms of sine alpha only. We can, however, also do it for the cosine, where we're going to take directly from this one. We say we can write down the sine as the subject of the formula. Sine squared alpha would be 1 minus cos squared alpha, which means if we can come back and substitute it here, where we see our cos 2 alpha would be equals to, remember it was cos squared alpha minus sine squared alpha. So where we see sine squared alpha, we can write it as 1 minus cos squared alpha. So this will just simplify to 2 cos squared alpha minus 1, and that would be equation 3. So we've now derived the 3 equations for the compound angle for cos. This one is in terms of cos alpha only. So these double angles for the cosine can be written in terms of both the cosine and the sine, or in terms of sine only, or in terms of cosine only. Right, we move on from this. We get to the summary of the formulae as they appear in the formula sheet, the double angles formula. Obviously, we've worked through the compound angles. Let's check now the double angles. This one is for the sine. We worked through it. And this one is what we called equation 1 on the previous slide. This one is what we called equation 2 on the previous slide. And this one is the one called equation 3 on the previous slide. Now, these formulas here now means we have a complement of all the formulas that are in your formula sheet. The first four, these ones are for compound angles. Compound angles, we've worked through them, and then these ones here are for double angles. So now we have a full complement of the formulas. It means now we have to go and apply them. Right, let's check now the example. Express the following as a single trigonometric ratio and simplify if possible. So I have 2 sine 15 cos 15. I'm bringing along my glossary here for the double angles. I can see that it looks like this, where alpha here is 15 degrees. So this can be written as what? This can be written as sine of what? 2 times the angle 15, because here if we have 2 sine alpha cos alpha, we express it as sine of 2 times the angle alpha. So let's work through that. Let's see here. The sine of 2 times the angle 15, which is the sine of 30. When we simplify that, we get that it's equals to half. So that's what we were supposed to do there. Right, we move right along. Example 7. Oh, it's activity 4. Activity 4, this is a short one. I am just going to give you 2 minutes to work through that. 2 minutes. You should be able to have a solution by then. So your 2 minutes time starts now. Right, hello and welcome back. Okay, let's look at this one that I gave you. I'll check here first. I want to check with our glossary. Obviously, we are always making a reference to our formula sheet. Now, if you check, this is 1 minus 2 cos squared 2 cos squared, we see it looks like this one. We see that it looks like this one. So we are having 2 cos 2 alpha as 2 cos squared alpha minus 1. The only problem with this is that the signs are the other way. The signs are the opposite of what is in the formula. In the formula, 1 is negative. Here, 1 is positive. 2 cos squared of the angle alpha is positive in the formula, but here it's negative. So first things first, you are going to take out negative 1 as a common factor. So let's see. I took out negative 1 as a common factor. Now this looks exactly like that, where now alpha is equals to 15, which means if we want to simplify this, we're going to have cos, it's cos of 2 alpha, which is 2 cos squared alpha minus 1. So where we see alpha, we put 15, so this would be cosine of 2 times 15. Oh no, it's 22.5, sorry. Alpha is 22.5, my mistake there. So this would be the cosine of 2 into 22.5. This would be 2 cos squared 22.5 minus 1. So it looks like this, 2 cos squared 22.5 minus 1. So simplifying that, we get negative double 22.5, and then this becomes negative cos 45, which will then ultimately take us to negative root 2 over 2. Right. That's all as far as this problem is concerned. Let's move on. Now let's look at problems involving Pythagoras theorem and diagrams. Problems involving Pythagoras theorems and diagrams. If 4 tan theta minus 3 is 0 and theta is trapped between 0 and 180 and 360, calculate sine 2 theta without the use of a calculator and with the aid of a diagram. Now, here, first things first, we must write down this and make tan the subject of the equation. Right, let's check here. If we make tan the subject of the equation, we get that the tangent of theta is 3 over 4. And then from there, after working out the tangent of theta as 3 over 4, we know that the tangent is what? The tangent is opposite over adjacent. So it's y over x. So the tangent is opposite over adjacent. It's y over x, which means that x is negative 4 and y is negative 3. When we draw the diagram, how are we going to draw the diagram? We can see that here, tan is positive. So we're going to locate where tan is positive. Tan is positive on the first and the third quadrant. And then from there, we are told theta is greater than 180 degrees, but less than 360, which means that theta is now here or there. Now we're going to look at where we have two markings. We have a tick and a cross. We see it's in the third quadrant. That is why our terminal arm will then be in the third quadrant, as you can see it here. So now we check on the third quadrant, we know x is negative, y is also negative. So that is why we say x is negative 4, y is negative 3. Now we are left with calculating r. So we get that from Pythagoras, we can calculate the value of r. X squared plus y squared is equals to r squared. That is from the Pythagoras theorem. And then from there, we substitute x with negative 4, we substitute y with negative 3, and then we get r as 5. R is equals to 5. So now we have x, y, and r, which means we can be able to determine anything that we want from here. So if we check here, we want sine of 2 theta. We first write it as what? as the formula for the double angle, because sine 2 theta, we get it from sine of 2 alpha, which is 2 sine alpha cos alpha from the formula sheet. Now from there, we are going to say sine is y over r, cos is x over r. Now we substitute the values of x, y, and r in that, and then we get that this is 2 into negative 3 over 5 times negative 4 over 5. And then from there, we are going to get that the sine of 2 theta would be 24 divided by 25. So that's how you were supposed to work with this particular problem. Right, I have a problem here which you were supposed to go through, but because of time, we are going to move on from this particular problem and look at the last concept, because we are almost out of time and there's a concept that I still want to do with you. So this problem, you were supposed to go through it, but you can just take a screenshot of that problem. You will work it out later on in your leisure time. Right, I'll just move quickly through that particular problem and what you were supposed to do there. Because you had two angles, alpha and beta, you were supposed to work out the triangle, or rather the diagram for alpha and the diagram for beta. You work them out as separated entities, and then from there you are going to find x, y, and r that are associated with angle beta, find x, y, and r that are associated with angle alpha, and then from there you are going to be able to answer the question that was asked. You will be able to do that with ease. Right, I want to then move on to the last concept. The last concept is on trigonometric values represented by letters. I think we will have enough time here for you to also do an activity, because I'm very much interested in seeing what you can do with the activity that I'll give you. We are given cosine of 25 is k. Determine the following without the use of a calculator in terms of k. Now, first things first, it is much easier if you work with this and you have a diagram. So I am going to draw a diagram. We have cos 25. So because it's in the first quadrant, an acute angle is in the first quadrant. So if this is angle 25, we check, we have the cosine of 25 and is equals to k divided by 1. And we know that the cosine is adjacent side x over hypotenuse side r. So the adjacent side is k, the hypotenuse side is 1 there. Which means that if we use x squared plus y squared is equals to r squared here, we can be able to work out that our y should be the square root of 1 minus k squared by making use of the Pythagoras theorem. So our y would be 1 minus k squared if you use Pythagoras. Then we know that this is 90 degrees. And the complement, we find we want to add all angles. We know they give us 360 degrees. So we want to know what the third angle would be there. The third angle would be 65 degrees. That third angle is important because sometimes the questions would be asking you to use that third angle there. Right. Now let's check how we were supposed to then work on that after you've drawn the diagram. Obviously, I am now showing you step by step how I worked out the value of y there using Pythagoras. Y squared would be r squared, which is 1 squared, minus what you call x squared, which was k. And then we get that y is the square root of 1 minus k squared. Now we can start answering questions. This is 155. We are going to reduce it because it is an obtuse angle. We'll reduce it to an acute angle. So we would have that this is 180 minus 25, which makes us, which reduces to negative cosine of 25 because we are on the second quadrant and the cosine is negative. So we see that we have negative cos 25. We're given cos 25 originally, so this would be negative k. It's the first one. The second one is the cosine of 50. You can see that 50 can be written as what? 2 times 25. So it's a double angle for 25. So we can work it out that way, as cos 50 is cos 2 times 25, and then we can choose from any of the three cosine formulas for the double angles. We can choose any. I will choose the one where is written as cos only because I already have cos given to me there. So it's 2 cos squared 25 minus 1 using the double angle formula. I know what cos is, so this reduces to 2k squared minus 1. And then last but not least, the sine of 25. We go there, we see we have 25 there. The sine of 25, it would be opposite over hypotenuse. That is y over r, and that would simplify to square root of 1 minus k squared over 1, which is the square root of 1 minus k squared. So that's how you were supposed to simplify that. First, you draw a diagram in the first quadrant because this angle is 25 degrees. It's in the first quadrant. And then you write down the k value as a fraction so that you know, because it was the cosine, that it's x over r, and that would then yield, take you to the diagram, fill in the value of x and the value of r, and calculate the third one, which in this case was the value of y, and then we can start solving questions from there. But it's important also, good people, to write down the third angle there. Right, there is your problem here. I want you to only focus. When I do corrections, I'll do all of them, but I want you to only focus on A, or rather on B and C. I want you to only focus on question B and question C. I am going to give you just 3 minutes to do that. Focus on question B and question C, 3 minutes, or I'll just make it 4 minutes. B and C, please make sure you write that as quickly as you can. Your 4 minutes time starts now. Right, hello and welcome back, good people. Let's work through this last problem and see how best you can actually attempt this. Right, let's start. Obviously, it starts with the diagram. We have the sine of 12, sine 12. This is equals to m divided by 1. And the sine, we know it is y over r. That is the opposite over the hypotenuse. So we are then going to draw our diagram. Draw our diagram in the first quadrant. We know the angle is 12 degrees, it's acute. And then from there, sine is y over r. Y is m, r is 1. If we use Pythagoras here, we would be having x squared plus y squared is equals to r squared, which means that x would be the square root of 1 minus m squared. So this would be the square root of 1 minus m squared. And then to get the third angle, we would say 90 minus 12. We get that the angle here is 78 degrees. And the angle here is 90. Now we've completed that. Now, if you check, the second question is asking you about 78. It was not in the original diagram, but because you have worked out the third angle, you are able to see that, oh, there is 78. And I want the sign which is opposite from 78, opposite side over the hypotenuse side. So I would have that this is square root of 1 minus m squared divided by 1, which would be the square root of 1 minus m squared. So that's what you were supposed to do. And then let me take you through all the others as well. Tan 12, tan obviously is opposite over adjacent. Let's go. I'm starting with determining here it should be m, not k. So y squared is the square root of 1 minus m squared. Made a mistake there with k. Should be the square root of 1 minus m squared. And then from there, the tan of 12 degrees, tan is opposite over adjacent. Opposite is m, because remember, I'm looking at y over x from 12 degrees. Opposite over adjacent. The opposite is m, the adjacent is that. I'm done with tan 12. I go to sine 78. I've already taken you through that. 78, its opposite, which is 1 square root of 1 minus m squared over a hypotenuse, which is 1, and then you get the square root of 1 minus m squared. And then the third one, which is the sine of 6. Now, if you look at the formula sheet, we have that the sine of 2 alpha, this is 2 sine alpha cos alpha. Now, if you check this one, it does not have that 2 there that you need. So you are going to multiply it by half times 2 so that you can be able to use the double angle formula there. So we write sine 6 cos 6 as half times 2 sine 6 cos 6. We know 2 sine 6 cos 6 would be the sine of what? 2 times 6, which would be the sine of 12 degrees. So that is where we got the sine of 12 degrees. Sine 12 was given here as m, so that would be half of m. Now the third one, this one, since we have, you can see we have an expanded version, cos, sine, sine. So this means that we need cosine of what? Cosine of alpha minus beta, which is cosine of alpha plus beta, which is cos alpha cos beta plus sine alpha sine beta. So it means that we need to congest that using the compound angle. So we will get that this would be the cosine of 58, because we are going back 58 plus 20. That's the cosine of 78. You can see 78 is on the diagram. and the cosine is adjacent over hypotenuse, which would be m divided by 1, which gives us m. So that's how you were supposed to do it. Please, good people, make sure you practice this because it is not difficult work. Put your formulas next to you from the formula sheet. Look at what the question wants from you. Apply yourselves. This is not that difficult for you to not be able to get marks. Right, I am concluding. I had a activity 7 which I would have wanted you to do if we had time. This is a very nice question. It's of high order, but I am going to move away from that because I've actually run out of time. I am not going to be able to take you through this question of high order. Very interesting question. Unfortunately, because of time, we cannot work on that particular question. Now, let's summarize everything. To be competent, you should be able, in trigonometry, in this basic trigonometry, you should be able to understand how to use this formula, the cosine of a minus b expansion, to prove the other compound angle identities. We started there when we started our lesson. You should be able to use compound angle formulae to solve problems where expansion and congestion of formula is applied. You would remember in the first part of the lessons, I put down on the left hand side the glossary, the formulas from the formula sheet, and I showed you how to move from left to right and also from right to left on that formula sheet. And then you should be able to use the compound angles to derive the formula for double angles. We did that as well. You should be able to use the double angle to solve problems where expansion and congestion of formulae is applied. We did go through that as well. We also worked on Pythagoras theorem problems where we drew our own diagrams, and we also worked with some trigonometric ratios represented as letters there. So good people, we've run out of time today. Please make sure that you tune in also next week as we'll be continuing with our trigonometry, and please make sure that you practice and practice. So I am saying bye-bye to you now. See you next week. Take care of yourselves and take care of each other and practice mathematics. Goodbye.